Hey, Jacob. Can you hear me? Can you hear me? Hello? Hmm. I don't think I can hear you. Okay. Can you hear me now? What about now? Can you hear me? Can you hear me? Hello? Let me try this again. Can you hear me now? What is going on?
No, I can't unmute.
Oh wait, here you go. I can hear you now.
Cool.
Oh, that was weird.
Yeah.
Okay. All right. Let me just show you what I had. I think I sent you something, but were you able to open it?
Which one?
The work, the homework stuff.
The homework for problem 1, like I'm seeing right now.
Yeah, I sent you some of these.
Yeah,
I
I
think.
saw. Yeah.
What about the worksheets?
Yeah, I was able to open that.
Okay, good. Okay, I was just checking because what I didn't get a reply from like there was something there that you wanted to cover, but did you want to like go over the homework first
Yeah, that's fine.
or like the review? Probably like the homework, and then we'll talk about the review.
Yeah, let's do the homework and then do the review.
Okay. Uh, so I guess before we do this on how would you attack this problem? Like I was kind of just like looking back at how I did this problem before, and then they're kind of related in a sense, like 4 and 5, because then after you do what we did in like 3 and 4, and like 5 is like where it like puts it all together,
Right.
and then because you're gonna be doing like the derivative and then the integral. So I guess for 4 problem 1, do you like I guess do you know what a type 1 improper integral is?
Not necessarily.
Okay, so like from the way like I've been taught about this is there's always been like type 1 and then type 2, and then type 1 is when you have it as like this part right here. Here, let me get a pen. So this part right here is going from 1 or like a number to infinity, and then compared to a type 2, this wouldn't be when it's like only a number, so it's not continuous.
Okay.
So that's how you know. Like this is a continuous integral, pretty much going to infinity. And I think that's important because the way we would attack the problem, if it's like convergent or divergent, depends on whether you have a type 1 or type 2. And so the way you would for a type 1 improper integral is you would just follow what I did here, which is just like, so you have you take a limit from like, you replace that infinity with the b going to infinity, and then you technically solve this integral first.
Right.
And then after you do that, the way we were talking about last time, like applying those rules until you get to this point, and then how you would test if it's like convergent or divergent is after you implement or like plug in this limit to the variable, either b or a, whatever. And if you get like an infinity or irrational number, then this right here would mean that it's divergent. And if you get a finite number, like then that would mean it's convergent. If it's like a finite number, it's does that kind of make sense? Like that's I'm thinking that's how your professor probably taught you guys.
Yeah.
Yeah. Okay. So that's technically the rule. Like you're just applying what you did before, but then now you're adding the limit to it. And then I think your professor is not going to really confuse you, because from the way it's worded out on the review, if I remember, he kind of separated that portion. Like, okay, is this convergent or divergent? And you know that you have to do that. Like even if you see like a type 2, like for a type 1, it's very recognizable, because you're gonna say, oh, okay, there's an infinity there. So you're gonna have to, if he doesn't tell you, if this is convergent or divergent, explicitly, then you know if there's an infinity, you do have to check for that. So does this one make sense?
Yes.
Okay. So for the second problem, I think that, yeah, so this is where it starts becoming, maybe if you look at this like as a whole, it kind of just looks like, oh, you're not really solving like a convergent divergent problem. It's just like, oh, am I just gonna solve the integral? But then what ends up happening is, like if he tells you that like if it's a convergent divergent, then you just follow the same steps. And then this is the one where it's actually convergent. So, you know, you find the integral, you plug in the limit here. And then after you do that, you get an actual finite value. So that rule becomes like, if it's a finite value, it's convergent. And if it's like infinite or irrational value, then it's divergent.
Okay.
That's really the system of this homework. And then like maybe the hardest part is just, let me see if this is on. Yeah. So this one is kind of like, it is a type 2. It's usually the type 2s that like will give you a hard time. Because especially this one, because like what if the integral is really messy as well, and then you have to split it into 2. So for this one, did your professor talk about why you split it into 2?
Not that I remember.
Okay. So looking at this, like why you would do this, like the very first thing I would say like for these types of problems is classify if it's type 1 or type 2. So we got that established. And the second thing, if it's type 2, then you have to split it into 2. And then how you split the limits here, how do you know it's like from 0, why can't it be 0 to 1? Why can't it be 0 to 3 and then 3 to 4? Is this 2 that they share in common in the limits is where this equation, like if you plug in 2, you can see it, right?
Yeah.
Yeah, it's gonna be this guy, yeah. So you're gonna have something not defined. So
you have to define it at 2. So
yeah. So you still have to find the limit. You can find a limit, but you can't like solve for it. You know what I mean?
yeah.
So that's why that you can still find a limit there. That's why you're gonna do like at the left side of 2 and then at the right side of 2. So yeah, this is when this procedure is very like a lot of these convergent divergent for the tests is just knowing the different procedure. Like so for type 1, very easy. Once you know it's type 1, solve the integral, plug in the infinity, and then you can already assess if it's the convergent divergent. Type 2, I guess like type 2 category 1 or type 1 is just if you know that it's going to be, there's no you know, like the limits of integration has no discontinuity. Like from 0 to 1, that's already like at 1, that's when it's discontinuous here.
Okay.
That's when you just solve that part. For the most part, how I can tell like if you have to split it is if you have something like this, like 0 to 4, it's like it's going more than 1. If you go more than 1, or like some large value, maybe 10, you always want to check if you have to split it. So this type 2 part, category B type of a problem. Does that kind of make sense? So like this one right here, the reason it's like a category 1 type 2 is you're already, you know, this part right here, there's nothing in between like 0 and 1 that will make this undefined. But for the most part, how you recognize this type 2 category 2 is, you know for a fact that between 0 and 4 there's going to be some discontinuity, and then at that point of discontinuity, that's when you split it, the integral. Does that kind of make sense?
Yeah.
Okay. Yeah, that's really like the thought process of these. It's kind of like how I would go about like solving these. So after you split the sun, we kind of talked about this. These are just doing the partial fractions, and then solving the integral. And then the way I kind of arrange these so it's easy is like to always keep it bookmark or try to organize the way you solve your limits. So the left hand side is this guy, right hand side is that guy. So the left hand side, after I do this, did you get the solution for this problem by chance?
I think so.
Or I forget if your professor gives you guys the solutions.
He didn't. For homework, I haven't gotten any solutions.
Oh wow.
For like
okay.
the review.
Only for the review.
Yeah.
Okay, that's fine. We could always work with it. It's always like it's because for the homework, you would think that you would get it at least and everything, so that if it's always good to be more confident in the beforehand than
Yeah.
that. But that sucks. That's why I guess I'm here to figure that out. But okay, so for this part, like this is probably gonna be the hardest one, is when you get a type 2 category 2 type of problem. Is if the way you would assess if it's convergent or divergent is if both of these are convergent, that's when it's convergent. If one of them is divergent or the limit does not exist, which is like both of them for this case. So the limit doesn't exist for both of them. Then this is divergent.
Okay.
Yeah, that's how I would assess it. And I think let me look at this last one. Let me see. Okay. Type 1. Oh yeah. And this, I would probably so this problem 4. This is the one where it's continuous in both limits, like both limits of integration. So the way, like the way he showed you guys, was it a direct comparison test or a limit comparison test?
I would say what he had us do was he just had us take the limit as c approached infinity, and then you would just put negative c to c. So I guess the limit comparison.
Negative C to C?
Yeah. So like what you did with B, where you would say B approaches infinity, he just did that with C, and then he would just plug in C.
Okay. Because there's usually 2 ways of if I remember doing this, there's like the direct comparison tests and then the limit one. And okay, continue though. Like, so after that, how do you prove if it converges for the way he showed you?
Well, what you would do is you would just solve the integral, and then you would plug in infinity for C.
Kind of like what we did beforehand.
Yeah. Yeah, what we did here.
Let me think about this then. Okay. So do you still split it?
No, I don't remember him ever splitting it.
Okay. So, but then there's 2 infinities though.
Yeah. Here I can.
Here. Do you have a solution or like a way that you can show me?
Yeah, it was on the review how he solved it.
Okay. All right. Let's look at that one.
So I think it was. Let me see.
Yeah, because this can go about like direct or limit. I usually don't go with limit because you have to like guess 2 functions.
That's weird. Oh, that's annoying. I guess I lost my mind. He doesn't have an example of one on.
Oh, there was one?
On the exam, he doesn't have one that does that. So.
Okay, let me take a look at that one. Okay, I would just say like if he did ask for that, I would did he? So the way he said that, was that just a lecture? like the way he mentioned and you mentioned it? Is that the referring back to his lecture?
Yeah, I guess I am referring back to his lecture when he said,
Okay. Cause so I guess can you explain again how he did it? So like maybe I can interpret it.
so what he did is he would have the limit as c approaches infinity,
Okay.
and then he would just plug in c for both infinities, except the one that the negative infinity would just be negative c, and then it would go to positive c, and then
I
he would
see, I see. So it's just gonna be one variable, but then it's for both.
yeah,
And then he would solve the integral and
yeah,
and and evaluate it and then put in the infinities.
yeah.
Okay. Yeah, that works. And then if you get an infinity, then as like the aggregate answer, then it's a
It's
divergent.
yeah.
And okay. Otherwise it's convergent. Okay. Yeah, just do it that way. We don't need to do like because this is the way I've how you would do a direct comparison. Like you have to
Oh,
prove two things, but don't do it this way. This is just like how I was taught. Yeah, that way seems like pretty much just applying what you know from like because this is just the applying what a type 2 type 1 are and just solving this uh when he says comparison test.
okay.
Okay. All right, let's move on to homework 5. All right. So is it still fresh in your mind what he talked about lengths and surface of curves? Do you remember the equations for those?
No, those are yeah. No, really. Yeah, no, it's not fresh.
Okay. So when they typically ask you what a length of a curve is, this is the equation that you have to apply. This is the easy one. There's actually a clarifying question that I have because it seems like for the surface of or the area of a surface, and he gives you guys like a different limit, but then he's asking you the opposite, which is really maybe you can clarify that later on. But anyways, for a length of a curve, the main equation to apply is this guy. So it's typically L, and then this is just applying derivatives and integrals. And where that happens is so you're typically given, this is usually what's given to you, which is y equals a function. And then, this is evaluated from A to B, which is what this is the problem. This is just a general one, but this is the problem. So he gives you this, and then you have the very first thing I would do is find dy dx, and then after that, use this equation to find L. It's a two-stepper pretty much.
Okay.
And so that's what I did here. I found dy dx. Really simple for the function here. And then, but what's not so simple is like the integral as usual. So I'm not really gonna like. Do you want me to go over how I did the integral? I didn't do it for like, all of them. I think this is the only one I did it for.
Yeah, I mean, we can go over the one you did.
Okay. So for this one, you just plug it in. And then, okay, typically you do like a U sub. And then for this one, it's not very clear, but what I did was like, for the purposes of making this easy, I just did U equals arc sine H. It's hyperbolic 2x. And then the du is this guy. And then this is just the way, like here, it's just me rearranging this part so I can sub for these guys.
Okay.
So after subbing for them, so I saw that there's this trig identity. The sine H squared U plus 1 equals cosine H squared U. This one can be plugged in the term inside the square root. So I did that. And then there's another trig identity. sometimes like with a lot of people, they have a hard time figuring out, or you know how like you have this hyperbolic and then the harmonic, the periodic
Hmm.
trig functions. Sometimes it's not as clear for hyperbolics. So maybe have that handy, kind of just like your trig identity for your hyperbolics. Because for this problem, I didn't think I was gonna do a lot of that, but it was very much needed. And so what I ended up doing here is just I kind of just separated. So why I did this is I wanted to work out only the integrand term, and then I took out the constant 1/2. So this is what's in orange, and so I split this, which is this guy, A, and this is what was evaluated for A, and then B is this term, which is really easy. I could have just left it the way it is, and then so this is pretty much just this putting A and B together. And then for this, so I left out the 1/2 as a constant, right? So that's that guy right here. And then the integral is evaluated as this. And then so after all these simplifications, I plugged in back the U. And then after I did that, I had to do some hyperbolic like manipulations to make it look proper. For the exam, you probably don't have to go as far as this. Maybe you could just leave it as what you have here. But what ended up happening is like all of this is just manipulating the hyperbolic to get to a form where it seems like it's simpler. So that's what I got.
Okay.
Yeah. So if you have if you remember, I have that like Wolfram Alpha.
Hmm.
Yeah. If you take a look at that, or if you've heard of Socratic.com, you could also take a look at that. It's free. Socratic.com. But like Wolfram Alpha Pro gives you like all cases in terms of like, oh, if you want to know the steps, like complicated steps of simplifying trig as well as like integrating and deriving. So
Okay.
yeah, does this make sense for like the length?
Yeah.
Yeah, it's pretty much like a lot of it is just the don't get so bogged down with the simplification, but the main concept is just right here.
Okay.
Yeah, and then now let's go a step further. So this is just the length of a curve. Now let's talk about area of a surface. So for a 3D, or like no, this is the length, and then so for area of a surface, what you want to do is it's the same equation. So just to compare it with like problem 2, this is because it's asking you 2 things. So problem 2 here is the length of the curve. It's asking for one thing, and then problem 2A, 2B, 2B is asking you for the surface. So if you take a look at this equation, let me use another color. If you take a look at this equation, and then this, yeah, this equation, you're gonna see that they're pretty much the same. The only difference is this x and then this 2y, 2 pi. And then the reason why there's 2 of these guys for the surface is it could be about the y-axis or about the x-axis.
Okay.
And like, and that's really gonna message him. That's why I was like asking what this problem was, like really questioning you guys, because the limits of your function is given as x, right?
Hmm.
But
Yeah.
then like, what was the question asking? Was it for the y? Like rotating the curve around the y-axis. So that's what confused me, because usually they typically give you the y. If they give you the x, then that's rotation around the x-axis is what it's supposed to ask you. But if it gives it to you, if it's given in y, like the limits of the function, then it's rotation around the y-axis. But this one is asking you a rotation around the y-axis, but he gives you the x limits.
I'm gonna assume that because he has had to update
The
certain
function.
update certain homeworks before because there were misspelling.
Oh, you're gonna. So, what do you think for this one? What happened, or what is it?
I mean, are we having a problem? Like, we're
If
trying
you,
to find the rotation around the y-axis, but did he mean x?
yeah. Let me explain why first, because like if you do go with what he's telling you, like rotation on the y-axis, I think you have
Hmm.
to do two things. Like you have to convert this. You have to invert this so that it's like x equals f of y. That's the
Yeah,
first thing, and then and then the second thing is now this is in terms of x. I think you have to plug in these to get actual y values now. So you have to do two of those, and then I don't know if those limits will be correct then. Usually, from what I've seen this problem in the past, whatever limit they gave you, um, is what they're going to ask you for the rotation. It's the same, like along the same lines. So x limits is supposed to be a rotation around the x-axis. So what do you think? Did anyone ask? Is what I'm asking.
no, I don't remember anyone asking. I mean, he
Okay.
hasn't said anything, so I'm assuming, I guess that's what he wants us to do.
Okay, and then that's when like I got into an issue because have you tried this problem yet?
Um, I can try contacting him.
Okay, no, because here let me just show you what I mean. So let me just minimize this a little bit. But if you look at this, let's use this guy. If you take a look at this function, right, and we want to convert it to x equals f of y, and I guess this is my issue. So we want to make it so that the x is on one side and the y is on the other side, right?
Yeah.
Yeah, and then so we could do this. So I guess 2x, x cubed, and then plus x, all right?
Right.
And so there's x to the fourth plus x, and then 12x. And then now, I guess I could cross multiply this. So how would I go about isolating the y?
Could you?
It only exists, like you can't really factor it.
Yeah.
It'd be one y. You're still gonna have, it's gonna be nonlinear is what I'm saying. It's like a
So,
nonlinear problem.
yeah, no. I think he meant x.
I think he meant x, right?
Yeah.
Yeah, it's like impossible. Like this is like not a problem. Like this, you can't continue with this problem if you if it's that way. It's not as obvious. Like it's obvious. I think you could do number three. I think if it's either y or x, but this one definitely you can't. It has to be x-axis.
Okay, yeah. Then I would say it's x-axis because I don't think he'd do that.
Okay. Yeah. Yeah. If you can like just clarify with him, I honestly I don't want to give you like the wrong solution if there's even a solution if it's that if that's the way he wants it. But okay. So assuming that it is x-axis, but you do get that right? Like why you have like that's kind of like it can be done. It's just very tedious. Like if it's asking you about the y-axis, this is gonna be the equation. And then if it's about the x-axis, this is going to be the equation for the surface, area of the surface. And then the differences here is just these guys. So if we're going to go with like the x-axis, this is what I did. So the very first thing, you always want to, well, for a, you're going to be doing the same thing. Yes, dy dx. So this is what I got. And then for the length, I just plugged that in here. And then I simplified it, determine the radical. and then I solve for the integration. I didn't show the integration, but this one isn't that bad. And then I guess after you plugged in the limits of integration, you're gonna get 31/48. So that one's like similar to what we did. And then finally, if you did the area of the surface, so this is our function again. Same thing, if you already had like the dy dx, you could just drag that down. And then the equation for this is, so this radical term stays the same. You could also drag that down. You only have to add this part, 2 pi. And then this term right here in front of the radical is just it's just the same as your equation. So the way I would like, let me think if you have to resolve it. Yeah, you still have to resolve it. What you could do is if you so I didn't show the integration here, is try to simplify this as much as you can until you know, it's easy to integrate. And then so after you do the integration and then you know, plug in the limits to evaluate and times it by 2 pi. Oh, a lot of people they sometimes forget this part, the 2 pi. So I'm trying to carry that down. Carry down the 2 pi, which is just the concept. Like after you do a lot of like integration and go like, oh shoot, there's a 2 pi. And then so in the end, after you do all of that, this is what I got.
Okay.
So the concept isn't that hard. It's always the thing that makes it so difficult is just solving the integral by hand. That's the only thing that makes all of these difficult. Even the derivatives aren't that bad because it's only first derivative.
Yeah.
Yeah. Okay. Let's see. So that concept makes sense for both the length of the curve and then the area of the surface.
Yeah.
Okay. Yeah, I'm pretty sure this equation is in you guys' like notes. So it's open notes, so you don't have to memorize anything. Just know how to apply it. Okay. So for problem 3, it's pretty much, yeah, I think this one, since he gives it to you again in y, I just assume this is going to be about the y-axis because he gives this to you in y. For the exam though, maybe you want to ask him.
Yeah, I'll ask him. I'll
Yeah.
ask him about the other question and that.
Yeah. Yeah, maybe clarify, like, do you know if we're given the limits in y, is it safe to assume you want it to be about the y? Yeah, stuff like that. This one, if you were to do it about the x, yeah, it's not that bad. I mean, this is about the y. So if it's about the x, you would just do like 1 minus, I think it's pretty much the same thing. You just switch it because they have 1 minus x 2/3, 3/2. But then your y is still 0 to 1. So what I would do to change this to it, you just plug in 0 here, and then solve for x, and plug in 1. Like y equals 0, y equals 1, and solve for x. And then you'll get like a range. You'll get a number, right?
Yeah.
Yeah, and then this will be that number. If this was asking about the x. Okay, so for this one, similar. So since this one typically, you assume that it's given to you in like where you isolate the x or the y. If it doesn't, manipulate it. And then after that, just apply the surface area equation. First thing here is like, if this is about the x dy, right? So make sure you're finding the right integral. I mean, the right derivative. It always has to match. It just depends on how you're applying the equation. So this one is dx dy is the one we need to apply. And then for this dx dy, after you get the dx dy, you plug it in, the surface equation, and you have the 2 pi here. You have the, I think this is the x term, the dx dy, and then those 3 parts you plug in, or remember this, you plug in these 2, and then you carry out the 2 pi. Don't forget that. Evaluate this within the limits of integration, and then simplify, and you're gonna get that. So this one is, the answer is nice. I think the way you do the integral, it isn't that bad. You do some manipulation. But yeah, for all the concepts for homework 5 isn't that bad. Does it make sense?
Yeah.
Okay. Yeah, let's do you want to go over like the review?
Yeah, let's go over the review.
Okay. Here, I'll let you share your screen.
Is this the review or is this answers to question? No, this is the review. Okay. Share screen. That screen. Share it. Okay.
Let me get some water first. I'll be back in a bit.
Okay.
All right. Okay. Yeah, so let me see. So what did you do all the way up to 31 already?
Yes.
Okay. How was that?
It was iffy.
Yeah, I bet. Like usually doing a lot of this, so it gets very tiring after like the 5th one. Were there any so you understood all of those things that we talked about last time?
Yeah.
Okay. And then like after like this, the concepts, I guess, for improper integrals, do you think you can, so the concept isn't that bad, right? Like evaluating if it's convergent or divergent.
Yeah, no, that's not that bad.
Yeah. Did you want to go over one of these?
Yeah, let's go over one.
Okay. Which one?
Let's try 36.
36? Okay. Let me take a look at this. Let me write that one down first. All right, sample. And your exam is when? Is it on Wednesday?
Friday.
Oh, it's a Friday. Okay, you have a lot of time. My other client, his exam is on Wednesday, so, but his is like applied calculus. Yeah, and like I don't know. So this class is are you guys talking about applied anything yet?
No, not yet, but
Okay.
that is coming up.
Yeah, I think those are more fun. It's like, you know, I don't know. Like, which one do you think? Do you like all this rigorous math stuff, or do you like it when it's like, okay, finally there's a picture?
The picture's nice.
Yeah, I know, because then you get to at least see like the end of the road, you know, like
Yeah.
why you're learning this. Yeah. Okay, so let's look at 36. So 1, 0, x minus 1, root x dx. So I'm looking at this. This looks like a type 2.
Yes.
Yeah, type 2, and it's like category 1. I don't know, that's just my own thing, but it's a type 2 category 1. And so you just take the limit, b to 1 to the left. Okay, let me just take a look at this one. Wait, this isn't even discontinuous, right? Oh no, it's 0.
Yeah.
It's not 1, yeah. What is going on? Okay. Will he penalize you guys if it's like you put like plus or minus for like the limit? I mean, it's not that bad, but
No, I wouldn't assume so.
because it doesn't really make a difference, but it's just technicality. Okay. That's 1 and 0 minus 4/3. That's plus 1, 1. That's 2. What did you get for this one?
Still getting there.
Okay.
Is this continuous?
Or which one?
For 36.
It looks like it's just like a typical integral, if you think about it.
Okay.
I mean, yeah, if you do plug it, like the function itself, like not the integral, like the function is discontinuous at 0, but the integral isn't. Do you do a U sub for this one?
Yeah. So I did a U sub for X because doing the U sub
Okay.
for square root of X didn't make sense to me.
Yep, you could do that. Yeah, that's the way. Yeah. It's like there's only one U sub. It's not bad.
Then can we? Oh, okay. So
Okay.
then, so do we have the square root of U minus U to the or 1 or negative 1/2, right?
Yeah.
Okay, and then you just integrate. Gotcha.
Just integrate. Yeah. Yeah. These ones aren't that bad. I think 37 sound looks pretty bad. Well, I think that's like the one with like the two. This we have to split it.
Okay.
Okay, you got the integral.
Yeah.
Okay, what was your integral for that one? Or like I guess the form. Or did you already plug in? You could technically like you could shortcut this and plug in the zero and then because it does evaluate. It's not discontinuous. The function. Oh wait, the integral. So what did you get for it?
The integral or the.
For the or what part are you at?
Oh, I just finished the integral, so I'm just gonna plug in the
Okay.
X back.
Okay. Because once you have that zero part, it's like it's just gonna disappear.
Yeah, and then just plug in 1, which would it be 2/3 minus 2?
2/3 minus two, yeah, that's correct, yeah.
Yeah.
Negative 4/3.
Yeah.
Yep, and it's convergent. Yeah, these problems are nice. It's like it's a little applied, right? You learn how to do the integral, and now you learn like, oh, now we can like you learn limits and then the integral. Now you're applying both of that. You technically there's still not so much the real world aspect, but it's something. Probably not gonna see this again though. You sent me this guy, right? The review.
Yeah.
Let me take a look at it. Just look at the bottom. Okay, let's see. All right. Did you want to do another one like that or something different?
Let's do something different.
Okay, but so you have that fully graphs, like the improper ones. Or you want to do 37? 37 seems like a splitter. Like you have to
Yeah.
split it. Let's do that one. Yeah, 37. You know what I did before? Like just to increase my speed, I would just like make up a few of these integrals and just make out like the most ridiculous ones and see if I can how far you can get it at. Because then at least like if you create like a very complex function, you're never gonna see that in the exam, but at least you tried, like you could solve something like that. All right, so for this one, how would you split it?
Is it just going to be from 0 to 2 and then 2 to 4? Wait,
It's
no.
weird though. This zero part right here is like it's already discontinuous.
Yeah.
Let's see. How would you split that one? At zero, it's undefined.
So
Because like ln of zero doesn't exist. It's always greater than zero. So maybe it's just at zero. It's actually you don't actually have to split this one. I thought you did. It's kind of similar to the other one. All right, so if you do this, all right, let's see. Okay, so for this one, let me know what you get. What happened?
So I'm assuming we're doing a U substitution.
For this one, yeah. It's kind of similar.
How would you proceed with simplifying this?
Let me think. Try do integration by parts.
Yeah, okay.
Yeah, if you do that way, I think it's yep. Yeah. This one we should do like this one sample problem that's like really difficult. If you want to do it,
Okay.
yeah. This one I think requires you to do the split.
So I think I integrated it by parts.
Okay. Did it work?
That's what I'm wondering. So,
Okay.
so you would just have, would you have 2 times the square root of x times the natural log of x minus 4 times the square root of x?
For this guy, let me see. That's your integration by part one. Well, what? Say that again. This is your evaluated version. Like
Yeah.
okay. What did you get at the end? Was it 2 times square root of x ln x or log x
Yeah.
minus 2? Okay, that's one term. And then minus minus 2 integral of 1 over root x, I think. Does this look right?
2 over...
The df. The df here is 1 negative 2 root x. What was your VDU? UV minus
UDU?
V. Yeah, the second term, the integral, the minus integral
Yeah.
something.
Yeah. It was
Well,
u 1 over root over u, or root of u. And then
okay.
the v was 2 times u root of u.
Yeah, that works, yeah. And then just evaluate that term. Are you stuck there? That term can be the first term, the UV is correct. And I think you have to just evaluate that second term.
Okay.
What was your U again? Was your U just X or root X? Or not U, but like, yeah, U in this case, yeah, U and V.
Oh, my u is natural log of u.
Okay, and then your DV?
My dv was u, 1 over root of u.
Okay. Okay. Yeah, that's correct.
Okay. Okay. Then I simplify. Okay. That doesn't seem right. So are we doing integration by parts twice or just once?
I think just once.
Just once?
And because what depends on what you have for your the other term. Because it's if you get like, let me see, it's 2 root x integration 1 over x dx.
Yeah.
You might have to do another one, yeah. Because that one doesn't have a log anymore, but at least you have like a radical term and then some fractions. But isn't that like, you could simplify that, though, right?
Yeah. Yeah,
And
I mean, that's what I did.
after you simplify it, you should only have an x term. That's like I could either like a fraction or like a exponent version of it.
Should I only have an x term?
Yeah, because the radical x or root x, and then this 1/x should be able to you should be able to like simplify that, so that's like x 1/2 like minus 1/2. I think that's what that is. So that's like 1/√x, and you just take the
Okay,
integration,
yeah. So it's just okay.
and you just take the integration of that 1/√x, or x to the x negative 1/2.
So it's just the root x.
Yep.
Okay. Okay, and then just plug it in.
You got that one from,
Yeah.
or you got the term at least. Okay.
Yeah. So
What was your final answer?
the define like with 4 plugged in.
Yeah.
I got 3.5, but I could be wrong.
Let me see. Where did I put that thing? Negative what? Is that a negative number?
I did not get a negative number.
For this 37, right?
You said 37?
Yeah. Which one were you? I was doing another, like, just to check another problem out. Yeah. Which one? We're doing 37, right?
Yeah.
Yeah. I got and then that's 0 to 4. I got negative 2.455.
I did not.
I got like a finite number. So I guess if you get a finite number, did you at least get a finite number?
Yeah, but
So it's convergent. So I guess it doesn't matter what your integral is. It's just convergent. Yeah, like this was a difficult one, I think.
so was my integral right?
For my like, let me see. Let's check this one out, man. Integrate ln x over square root of x. All right, so the integral I got for that one, I got 2 root x ln x
Mm-hmm.
minus 4 root x.
See, that's what I had at first.
Yeah. And then?
And then that was it. But
And using only problematic part is so we'll find which is undefined. That's a little weird.
okay, yeah, I got the correct answer when I did that. So you said negative 2.45.
Yeah, what did you get?
I got negative. Beforehand, I only had the square root of x. But now, that was my second attempt. My first attempt had 4, but I just thought it was wrong.
So your final answer is negative 2.455.
Yes.
Okay, good. That's the one. Yeah. So it's convergent, pretty much.
Yeah.
All right. Let's try do something harder. Let me just see this one. Like, along these lines, like the improper integrals. Take maybe like 2 of those hard ones, and then we can move on to the homework 5, the last part. All right. Let me just share my screen. Okay. You want to do these ones?
Okay.
Yeah. Like, let's try number 11 first. So let me try this one. I think this is just, I guess, yeah, I'm going to add to it. It's just saying find the improper integral, but find if it's convergent or divergent for both of these. Well, let's start with number 11 first. So the x squared minus 9, okay. Here, x over x squared minus 9.
Okay.
And I think you have to do this one. -1 to 3. Oops. All right, let's see this one. What did you get for this one?
For the integral, I got 1/2 times natural log of x squared minus 9. And then I'm plugging in my 3 right now, which is just going to be 0.
Yeah.
1/2 times log of -1 squared minus 9, which I don't know what that would be. Would that be undefined?
Yeah, it's undefined. Everything is
Okay.
like 0. So
Okay. So
it's
then,
not hard. It's just like, oh shoot. Yeah, I was like, okay, that's undefined.
so
He might trick you with these ones. So like, yeah,
0.97.
that's like
So
with
it
the
just
logs.
does not exist. Yeah.
So both sides, if both sides don't exist, like this A and then B, if they don't both exist, or actually one of them doesn't exist, it's just divergent altogether.
Okay.
And if they're both convergent, they have to be both convergent to be convergent. To be divergent, only one of them does not have to exist.
Okay.
Yeah, so that's that. Then let's look at 14. Let's see. It's a little weird. What did you get for this one?
I got divergent.
What was your like integration?
I just did a u substitution for 2 minus x,
Okay.
and then tried integrating it from there.
And then, so what was your final?
1/2 times 3 times
Okay.
the cube root of x squared over 2. Or 4, I guess I could just say that.
Cube root of what? Of 4?
Over 4.
Okay, I think it's probably equivalent. Somehow.
Is it?
Yeah, let's look at it. So what was this thing? 1 over 2 minus x. Let's say integrate. Was it 1 over 2 minus x? 1/3. 2 minus x, 1/3. Yeah, it should be. It should be the one. And 3/2, 2 minus x to the 2/3. Let's try from 0 to 2. I'm just a little bogged down with like the second limit one.
Yeah.
The second limit is giving me like a like an imaginary number. Yeah, that's unnatural. It's giving me an so 2 point. Oh, come on, man. 2.703 I. Which is a little weird. How does that work? (2.1 to 5). Doesn't make sense. Okay, maybe that's the answer. A2 plus 1.561703 I. So I guess it's convergent, right?
Yeah.
Yeah, the integral is a little weird. Like after you put in the limits, but you still get a finite number. If it's real, maybe it's that's another issue. But this one, yeah, this something like this is probably like the hardest you ever see it. Splitting it, and after splitting it, you have to you get like an imaginary number. Oh, maybe that's another question for your professor. Because like a real imaginary and real number, they're still finite. It's only infinity that's like infinite, infinite, which would be like divergent. But if you get like an imaginary number, it's still going to be finite. So therefore, it's convergent.
Okay.
But that's just something to confirm. He'll probably not going to give you something like that. Okay. Are you still working on the integral for this?
Yes.
Okay.
What did I do? Okay, where did I get
Which one did you get?
I'm trying to type it in now. $2.381 for that.
Yep. Yeah, you got that part. Yeah. This one.
Yeah.
Yeah, the first term isn't bad, but like the one that confused me is this one.
Let me see what I get for that.
Because you have that big 5 term or number.
Hmm.
Tell me if you get an imaginary number. The 2 one, like the 2 limit, just goes to 0.
Right. So
It has to be imaginary, right? Like unless you have like a 5, like 2 minus 5. Like 5 minus 5. 2 minus 5 is like negative.
no, I think it's imaginary.
It is imaginary, right?
Yeah.
It has to be imaginary because 2 minus 5 is negative.
Yeah.
And then like you're taking the 1/3 of that. Oh wait, hold up. No, hold up. Isn't it -3 squared?
Yeah, no, because you have the 2/3.
Yeah. Isn't it negative? Never mind. Wait, let me see. Negative. It's 3. It's square. 3 to the 1/3 then. Or no. It's 9 to the 1/3.
Yeah.
There you go. That's the reason why. Check that out. -3 halves, and then it's like -3 squared. Then take the 1/3. Minus, well, that's gonna be 9. Then 1/3.
Which would be 3. Or no. Never mind. It's cube root. Never mind.
This is like a cube root, yeah. But it's not imaginary. That's what's bogging me down. It's like shoot. -1/3. What is that decimal? So it's -3.121. I'm gonna just delete that. Okay, and then the 2.382 minus 3.121. Is 0.739. It's convergent. Okay, that one was you had to think about that one now. Okay. Did you want to do like the review for chapter, or like I think it's chapter 8, homework 5?
Yeah.
Let's look at yours one, and then if we have time, we'll take a look at the one of the problems that I have for the review. All right. Which one?
Let's do 40 since it has us do X and Y.
That sucks. It's a set it up though, right? You want to do it? Yeah, like that one. What does he
Oh,
show
do
for
not
that?
solve. Okay.
What does he? What does the solution show for that one? Because
Where is
he was he was showing something that seems like a hard one.
solution 40?
Let's look at this one. Okay. Solve for x. That one's the easy one, solving for x, but the y one, okay. You solve for x, and then dx dy, I understand that one, yeah. Oh, he doesn't. Oh, that's what he's showing you guys? That's what he's telling you guys to do. That's a little different from the way I thought it was. Because the equation that I have, you know, like it's a surface if rotated around the x, and then surface rotated around the y. He's just changing the y and the x.
Oh,
Can you confirm that doesn't look? I mean, is that the way it's supposed to be? Because the way I was taught, like it changes your derivative as well, right? And then here,
let's see. I mean, I could probably look at like a lecture and see.
yeah, he probably has that like one equation. It's just that equation we need to like confirm. Yeah, that one, yeah. Let's just take a look at this. Yeah. There you go. There you go. So around the x-axis, you should have sent me this one. Then all things would be clear. So yeah, that's like the one I was like the book that I have that I usually refer to. It changes the dy dx and then the dx, like differential term. Like it changes depending on like if it's about the y and about the x. But then if we follow this, which we should, I guess you only have to find dy dx, and then everything is the same except if you're saying about the x-axis, you put in the y, like you know the y function, and then if it's rotated about the It's the opposite. If it started on the y-axis, it'll be the x, and if it started on the x, it'll be the y. It's always the opposite. Yeah. Does that make sense? Like, I guess that's
Yeah.
just a rule. Yeah. So it doesn't matter what your function limits are. It's always going to be a dx.
Gotcha.
That's a little different from the way I was taught it, but let's stick with that. It's easier to think about it. So let's look at how he changed this to like in terms of y.
Like the solution or there.
The solution, the solution. So the x one, so he puts in the y. And then what is the y though? It's just a variable. It's just a variable. He doesn't even plug it in. Okay. I guess you could do that too. So you see how what he did? Like the only thing is, if you're solving this for dy, then like you have to account for y as like one of the variables. But then if you're solving this around about the y-axis, then it's just gonna be the x, the second, like the last line there. The x is just another let me say 1/3 y cubed. So that's where you plug in the x function. But if it's just the x-axis, it's just gonna be another y variable. So that works out. Yeah. Does that make sense? Like for about the x-axis, you don't do anything. That y is just there, and then you just solve for the integration. And if it's about the y-axis, the x function, like in terms of y, you plug that in, and then you solve for the whole thing. That's just the mechanics of looking at it.
Okay.
Yeah. So I would say this is the hardest problem, and then just look at how he did both x and y. Do you want to do this one, or do you want to do something like kind of like show what we do? We could probably do that.
Yeah,
Okay,
you can do that.
let's do that. Yeah. All right, 40. So this one's just setting it up, right?
Yeah.
Okay, I think I got it. So that's two of them. Let's just see if you were to solve it. Let's see. Two pi, and then this one's 20.275. Okay. This one. Squared, okay. From 1 to 3. Okay. All right. Did you get like the mechanics that he showed you guys in the equation?
Yes.
Yeah, it's like because the harder part is the about the y, because then you plug in the x, and the other one is just about the x. You just put in the y. You leave it as is. Maybe let's do one where after this one, like where it's like about the like when where it gives you only like the x limits. Because I think if it gives you the x limits, you have to solve this because it'll be a dy dx instead of a dx dy, and it'll be a dx. Did you figure this one already?
No.
This was number 40, right?
Yeah.
Okay. Did you get S in terms of X rotation around the X?
Say again. The surf like S.
Yeah, in turn around the X axis. This one doesn't take that much effort. It just you have the Y term there,
Mm-hmm.
and then it's just finding the dx dy. What did you get for dx dy?
Y squared minus 1 for Y squared.
To the -2.
Yeah.
Okay. Yeah, and then for that you plug that in the dx dy and then equation for surface area,
Right.
and then that's it for the x-axis.
Okay. So what's the surface area equation again? Is it
It's
like
two.
the square root of 2 pi or?
Yeah, square root of 2 pi. 2 pi can be like outside. It doesn't have any variable in it.
Okay.
Yeah, so 2 pi, and then you have this like the y is in front of the square root, and then 1 plus like dx dy.
Okay. So y squared minus 1/4 y -2.
Yeah.
Okay. And then just
And for the what about the y-axis?
wouldn't that be 2 pi x?
Yeah. Yeah. Yep. Okay. And then everything is pretty much the same. The only thing changes is that x instead of y in front of the square root, it's an x. That's the only thing that changes.
Okay.
And then like so you see that x, right? So you have to plug in that function in terms of y.
Gotcha.
Yeah.
So we have. So do we just do 1, 3 for the
For the which one?
when we're plugging in to solve it?
Yeah. You just like what it gives you. You don't ever change that. Like whatever it gives you, the equation is defined as like y. The limits are defined as like y is from a to b, where a is 1 and b is 3.
Okay.
And I think this one you don't have to solve it, but it takes a long time. So does this kind of make sense for like
Yeah.
applying the length and the surface? So like I'll send you like the ones I was working on, like for today.
Okay.
And then like, did you wanna like how confident are you with all the problems you've been working on? I sent you that like the things that maybe you can practice on, and it may be helpful just to like do a lot of those. Like the more we do this, the better we are at our speed. That's always my thing with the more problems you do, and then because like in the beginning you're like kind of like murky with what the procedures are,
Right.
but then like after the fifth time you're gonna get tired and it's like, you know what, let me just figure this out. So that's when it's like it starts kicking in. It's like I'll do 5 and then muscle memory kicks in, and it's more like remembering the procedure, the first step, second step, and the concepts just kind of, because you know how to do the procedure, the concepts just come through. So did you want to do another one this week, or you think you're good to furnish up the speed drills?
I mean, I have class all week, pretty much
Yeah,
all
class all
day.
week.
Yeah, pretty much all day.
Okay.
So I wouldn't be available again until Friday or Saturday.
Oh yeah, I think that's what we did last time, right?
Yeah.
I think I was like, yeah. Let's for this one, let me know if you need another session, because I feel like you already got it. We talked about like the bits and pieces, and I'm gonna send you what I have, like what we did today.
Okay.
So like you can take a look at it if you have other questions. And like, do you wanna, like, maybe for the next couple homeworks, maybe we can just do so it doesn't pile up. Do you want to just do like a weekly one, like every Friday, or
Okay.
whenever
Yeah, that
do you
should
think
work.
do you guys think you're gonna get your new homework on Friday though, after the exam?
I don't know.
Okay.
Usually I'll know by like Monday or Tuesday.
Are you guys, because you guys already covered everything up to the exam, right?
Yeah.
Okay, I think he will give you the homework. Usually that's like my professors. Like, it's not like, oh, by the way, we finished on like Wednesday, and then I didn't give you guys time. So, okay, so yeah, let's meet on Friday and then talk about the next homework.
Okay.
Cool. All right, and then like, do you want to just keep on doing like the 2 hours, or I think that's good every week,
Yeah.
and then the exam week maybe we'll do more.
Okay. Yeah, that should be good.
Okay, Friday I'll just text you the details. But yeah, thank you so much.
Thank you.
I feel like you're pretty good at it already. There's like a lot of concepts I know, but it's just really getting through the nitty gritty, like each individual like rule, and eventually it'll become very natural for you. Like what? I mean, that's just what it is. And especially with this calculus, I'm hoping once we get to apply it, it's gonna get more interesting.
Okay.
And not so boring like this. Okay. All right, Jacob. Thank you, man.
Thank you.
All right. All right, let's see. This one,